Hey everyone, welcome to Sequence of Instructions. I'm here on LeetCode, about to do one of their easy challenges. This one's called 2Sum. Let's get into it. So the description reads, given an array of integers, return indices of the two numbers such that they add up to a specified target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay. So here's an example. You're going to give us some array 2, 7, 11, 15 and a target of 9, and they say because 2 and 7 add up to 9, we'll return an array of 0 and 1, which are the indices of the elements 2 and 7. Okay, so it seems pretty straightforward. I'm going to be doing it in JavaScript. Right off the bat, one of the ways I like to encourage people to approach solutions is to just think of the easiest way to do it first and then worry about refactoring it, making it better. The easiest way to probably do this, I think in my mind, might be 2 loops. So we'll loop through once, going 2, 7, 11, 15. And then we'll have a second loop. So when we get to 2, we'll have a second loop that looks at 7, 11, 15 and sees if they add up to 9. So we'll go. It's basically similar to bubble sort in that it's 2 nested loops. So let's make that solution first. Get it on paper, and then we'll move on. All right. So for we declare counter I, while I is less than nums.length, we're gonna go up. So we're gonna start at the very first element, move up to the very last element. Now we're gonna do this again with a counter. Call it j. Okay, so now I have my 2 loops. Again, going back to their example, when this starts off, we don't want to double count for j. So we start at 2, we only want to compare 2 to 7, 11, 15. When we get to 7, we only want to compare it to 11 and 15 because it's already been compared to 2. So we were actually going to set j2 is going to be I plus 1. All right, so that's going to say, because again it said, you may not use the same element. So if our target was 8 and our first element was 4, 4 and 4 would be 8. We would exit if we were counting, if we started I at, or sorry, if we assigned j at I. So j would point to the same element as I. If they were both 4, or if that position was 4, that would solve, but that would be an incorrect solution because it would be the same element. So we want to start at plus 1. The condition is the same though. We don't want to extend outside the bounds of our array, and we increment the same. Okay, so now we essentially just say, if I wanted to be really verbose, I might say the num that we're looking at is nums of I, but I think this extra variable definition is not needed. So instead I'm just going to take nums of I and say if nums of I plus nums of j equals target, we're going to return, spelled properly, we're going to return an array of ij. It doesn't specify what order they have to be in, but the example given has less than the smaller one first and the larger one second, so I'm going to replicate that. I will always be less than j because we're starting j off at I plus 1. So we're going to return an array of ij. Otherwise, there's some else that's implied. We're just going to check the next one. So we're going to keep going through this loop until this condition is true. I guess if it's not true, it doesn't say what to do, but we'll just return false. It says we can assume it has exactly one solution, but this is a habit of mine to just always have a return statement. I want to make a note that while I was talking, I thought of a way to improve this. Potentially, if we can assume, it doesn't tell us that the arrays are sorted. This numbers array is sorted. But if it was sorted, in the example, it kind of hints that it could be sorted, but it doesn't tell us, so I can't actually do it. But a way to improve this would be your inner loop, rather than searching. Well, first let's see if this works. No, I'll just finish my thought. So this inner loop, again, this is going to be the big O of this is going to be n squared because it's n iterations times basically n iterations again. The way you can improve this would be if you know nums of I, you know what number you're looking for. The number you're looking for would be target minus nums of I. So like our solving number, I'll call it. I don't know what else would say? You know your solving number. You know that in order for the solution to work, you need to see if this number exists in any of the remaining elements. And so really, instead of iterating them over all of them like this, if they're sorted, you could do a binary search. And then that would give you n times log of n as a big O, which is a vast improvement, especially with larger arrays. So that could be one way you could improve it if you can assume that the numbers array is sorted. But here, while it appears to be sorted, they don't specify that in here. I can't necessarily make that assumption. So this might be the best we can get at. Let me just go over it one more time, make sure we got it right. So we start I at 0. We go through each element of the numbers array. For every element that follows, we're going to check if the two of them add up to the target. If they do, we return ij. Otherwise, we're just going to return false. Okay. So let's run it, see if it works. Appears to work. Let's see if I got it. Beautiful. All right, so that was pretty easy. I talked about how to maybe improve it. Let's see how we did in the big scheme of things. Did I click that? Why isn't it letting me go? Oh, is it opening it maybe in a new tab? Nope. Why isn't this? Oh, here we go. All right, so we're right around in the middle there, slightly less than average. My guess is that they all did the same solution. My other guess is that these ones probably did the binary search and just assumed it would be a sorted array. And good on them for maybe having it work. All right, well, that's all for this challenge. Encourage you all to give it a shot. Let me know if you had different approaches to this one. And if you did, please feel free to leave a comment and share with the class. Until next time, guys, take it easy.